This is Activity 2, Trading Moves, from Lesson 5, Solving Any Linear Equation. And the trading moves means that you're supposed to work with a partner, with another student, and take turns solving this equation. So basically trading each time, or taking turns each time. So if you look at equation A, let's just see if we can see the answer without doing too much work. And so if you look at this, you have to come up with a -5 on the left side here. And do you see where that -5 comes from? This term right here, this is subtracting a +7 or adding a -7. So this is going to be -5, and this is -7. And in the same manner, this is subtracting a +2, so this is adding a -2. So this is a -2 over here and a -7 right here. Well, to get rid of this -2, you're going to add a +2 to that to add the additive inverse. So now do you see that a -7 plus a +2 is -5? So there's the -5. We'll go over that again in more detail. And then the +10x. Well, if you add a +6x here to get rid of this -6x, you're going to add a +6x right here. So +6x plus 4x is equal to 10x. So it's not too bad to get to this step. But let's do this in a little bit more detail. So first of all, I'm going to change this to adding a -7 and adding a -2. So that's using the inverse operation and the additive inverse. So you're not changing anything. You're not just changing the equality of the equation or what it means. You're just changing how it's written. So this is, instead of subtracting a +7, it's the same as adding a -7. So once again, the inverse operation of subtraction is addition, and you're going to use the additive inverse of a +7 is -7. Same over here, adding a -2. All right, so if you add a +6 to both sides to get rid of this -6, here's the +6 over here, and that's going to equal this 10x right here. So now we're left with the -7 equals 10x plus -2. So how are you going to move this -2 or get rid of this -2? You're going to actually move the term to this side as a +2 by adding +2 to both sides. So this is going to be 7 minus this 2 right here. And that's going to equal this 5. That's because you're adding a -7 plus a +2. Well, the way to calculate that is if you have 7 negatives and 2 positives, the amount that you have in excess, I guess is a way to say that. So you have 7 minus 2, you have 5 units in excess of 2 units. And those 5 units have to be negative because you have more negatives. So -7 plus a +2 is equal to -5, and you calculate that as 7 minus 2 is 5, and it's negative because you have more negatives. So -5 is equal to 10x, and over here this becomes 0 because you had a -2 and you added +2. So this equals 0, and then that +2 gets added on this side. Now we have to get this to a single x. We have 10 x's equal -5. Well, what is 1/10 of those 10 x's equal? So 1/10 of 10x, that's going to give you 1x. You have to look at the same fraction, same portion on this side. So 1/10 of -5. Well, 1/10 of -5 is a -5/10. And this, on this side, this 10 divided by 10, this cancels out. This is equal to 1. So how do you work with -5/10? How do you simplify that? Well, there's a couple ways to write that or say that. One is to factor out the 5 by dividing by 5. So a -5 divided by 5 is a -1 times that 5 that you divided by. And 10 divided by 5 is 2 times that 5 to get back to the 10 that you divided by. And these 5's cancel out. 5 divided by 5 is 1. And so now you're left with a -1 over 2, and that's the same as a -1/2, and that equals x. So right here, what I say here is we're going to write this fraction as factors. Negative 1 times 5 and 2 times 5. You know you want the 5 here because 10 is, the factors of 10 are 2 times 5. And notice we talked about writing negative fractions a while ago. So this is a negative 5 over 10. That can be written as a negative 5/10, a negative 1 over 2, or a negative 1/2. So you can move that negative sign around depending on how you want to look at it, how you want to use that to figure out the value of x. For problem B, notice these parentheses here. This is a term inside parentheses. So you have 1/2 of a group. And in that group are 7 x's and 6 negatives. It says minus a positive 6, but I'm going to say add a negative 6. So we should get rid of these parentheses pretty early on. Before we do that, I am going to change the subtraction. So subtracting a positive 6 to adding a negative 6. Once again, it's the inverse operation of addition and using the additive inverse of a positive 6, which is negative 6. Same over here. Inverse operation is addition. Additive inverse of a positive 10 is negative 10. So 6x plus a negative 10, 7x plus negative 6. Now, to get these terms out of the group, out of the parentheses, a couple ways to do that. One way is to distribute this 1/2. And the other way is to multiply through by 2. And I'm going to talk about multiplying through by 2 a bit later. So let's distribute the 1/2 first. So if you look inside that group, what it means is you have half of a group. So you have half of 7x's and you have half of negative 6. So 1/2 of 7x's and 1/2 of negative 6. That's distributing this 1/2 to the 7x. So you have 1/2 of that many and 1/2 to this negative 6. So you have 1/2 of that many. And on the right side, you still have 6x plus negative 10. All right, so 1/2 of 7x is 7/2 x's. I would keep this as 7/2. Don't change it to a mixed number. Just leave it as 7/2 right now. Plus negative 3. So 1/2 of a negative 6 is negative 3. So now we're going to get the x's on one side and the numbers on the other side by using additive inverses. So to get rid of this negative 3 and actually move this term over to this side as positive 3, we're going to add positive 3 to both sides. So this becomes 0, and this is a negative 10 plus positive 3, which equals negative 7. The 6x is still there, and the 7/2 x is still there. So now we want to move this 6x over to this side. And I'm going to change the 6 to halves. I have halves over here. I know I'm going to want to combine these 6x's with these 7/2 x. So I'm going to change the 6 to halves, and that's 12/2. So you multiply by 2 over 2. 2 times 6 is 12, and that's 12/2. So now I can add a negative 12/2 x to both sides. I can get rid of this term and move the 12/2 x over to this side as a negative 12/2 x. So now we have 7/2 x plus a negative 12/2 x, and then it gets kind of tough to talk about, but that's a negative 12 plus a positive 7. So you subtract their absolute values. 12 minus 7 is 5, and it's a negative 5 because you have more negatives than positives. So this is a negative 5/2 x. And over here, this becomes 0, and this is negative 7. So you have negative 5/2 x equals negative 7. All right, so this gets a little bit tough to deal with because you have to multiply by the multiplicative inverse of a negative 5/2. And that is a negative 2/2. And let me go through one way to think about that, which hopefully makes it clear why it's a multiplicative inverse. So look at this negative 5/2. I'm going to get rid of the negative for a while as I talk about this. So just focus on the 5/2. So if I double this 5 halves. So 2 times 5 halves, that equals 10 halves. And then, so that's this multiplying by 2. And then if I take 1/5 of 10 halves, 1/5 of 10 is 2. 10 divided by 5 is 2, or 1/5 of 10 is 2. So now you have 2 over 2, and it's a negative 2 over 2. So this becomes, it becomes a positive 2 over 2, because you're multiplying a negative times 2/5 times 5 halves, and this negative times a negative is a positive, and the 2/5 times 5 halves. So these 2's cancel out because you're doubling the 5 halves, and these 5's cancel out because then you're taking 1/5 of what was 10 halves. So this all cancels. I think I made a mess of this, times x. And so on this side is the multiplicative inverse of a negative 5 halves, which is a negative 2/5. So now we're down to x equals, so here you can factor out these negatives and look at them as a negative 1 times negative 1 times 2/5 times 7. And that might help you remember that a negative times a negative is positive, because if you factor out the negatives, that's the opposite of a negative 1. Well, the opposite of negative 1 is positive 1. So a negative 1 times a negative 1 is positive 1. So this becomes 1. And now it's 2/5 times 7, which equals 14/5, which simplifies to a mixed number of 2 and 4/5. 10/5 is 2, and you have 4/5 left over. So this is 2 and 4/5. Now we want to check that in this equation. So this is a little bit tough to do. You have 1/2 times 7 times 14/5 minus 1/2 of 6. And you have 6 times 14/5 minus 10. So you have to be careful. You can't, let's say it this way, you have to multiply this 1/2 times 6 separately. You can't multiply these guys together, these factors together, and then subtract 1/2. You have to subtract 1/2 of 6. So it has to be minus 3, which is 1/2 of 6. 7 times 14 is 98, and that's 98 tenths. 2 times 5 is 10, so that's 98 tenths. So on this side, we have 98 tenths minus 3. On this side, we have 84. 6 times 14 is 84/5 minus 10. Well, how can we deal with this side? We want to subtract 10 from 84/5. One way to deal with that is to make this term into fifths by multiplying by 5 over 5. So this is 98 tenths, which is the same as 9 and 8 tenths. It's like having 98 dimes. 98 tenths, that would be $9.80, or $9.08, or 9 and 8 tenths. All of that minus 3. Well, 9 minus 3 is 6. This becomes 6 and 8 tenths. On this side, have 84/5 minus 50/5. I changed this to fifths by multiplying by 5 over 5. So 5 times 10 is 50. 50/5 is equal to 10. So it's 84 minus 50 is 34/5. And 34/5 is 6 and 4/5. 30/5, 30 divided by 5 is 6. You have 4/5 left over. And 4/5 is the same as 8 tenths. 2 times 4 is 8. 2 times 5 is 10. 4/5 equals 8 tenths. So 6 and 8 tenths is equal to 6 and 4/5. So the answer does check. Now, this gets pretty tough working with the fractions, although you should practice working with those fractions. Don't avoid them. Continue to practice working with them. But another way to solve this equation is to multiply through by 2 and get rid of the fraction. So 2 times 1/2 is 1. So now you're going to have one group here, but you also have to multiply each of these terms by 2. And remember, I'm going to change this to adding a negative 10 and adding negative 6. So 2 times 1/2, so you have half of a group. Then if you double that, you have one whole group. So that gives you 7x plus negative 6 equals 2 times 6x. plus 2 times negative 10. So remember, you have to multiply 2 times each term. People make mistakes because they forget. Maybe they multiply just this term by 2 and they forget this one. A variety of ways to make mistakes. You just have to remember to multiply everything by 2, and you're multiplying both of these terms by 2 because you're multiplying this 1/2 times 2. So this becomes one of these whole groups. That's 7x plus negative 6 equals 2 times 6 is 12x. 2 times negative 10 is negative 20. Now remember, the answer was 14/5. So where do we see the fifths? We're going to move the x's to one side and the numbers to the other side. So I'm going to add negative 7x to this side to get rid of this positive 7x. So I'm going to add a negative 7x over here. So now we have a negative 7 and 12. Well, what does that combine to equal? That's going to be the 5 right here. So you're going to end up with a positive 5x. So this is negative 6 equals 5x plus negative 20. So there's the 5 right there. There's the 5 right there. And now you can see you're going to end up dividing by 5 or multiplying by 1/5 to get rid of this 5 as the coefficient. So you're going to end up with 5 in the denominator. And do you see the 14? 20 and 6 can combine to equal 14. 20 minus 6 equals 14. So I'm going to add a negative 20 to this side to get rid of this 20. So I'm going to add a positive 20 to the side, get rid of this negative 20. I'm going to add positive 20 to this side. So 20 plus a negative 6 is 14. So there's the 14. And now it's 1/5 of 5x, and it's 1/5 of 14. So that's 14/5 is equal to x. So think through it. Practice saying it to yourself. In problem C, there are a couple of ways to work with this 1/2 x. One way is to, I'm going to label this x here. This is actually 1x. And then I'm going to change that 1 to 2/2. So now I can add a negative 1/2 x to this side to get rid of this 1/2 x, and add a negative 1/2 x to this side and add this to 2/2 x. Well, 2 plus a negative 1 is equal to 1. 2 minus 1 is 1. And it's a positive 1 because there are more positives than negatives. So this becomes a positive 1/2 x. And you're left with this 7 and this 13. And you add a negative 13 to get rid of this positive 13 here. That negative 13 shows up on the other side. And negative 13 plus 7, well, 13 minus 7 is 6. But that's a negative 6 because there are more negatives. So now you have a negative 6 equals 1/2 x. And you can get rid of this coefficient of 1/2 by multiplying by the multiplicative inverse, which is 2 over 1 or just 2. So remember that the fraction 2 over 1 is the same as just the number 2, and usually we just write it as 2. So 2 times 1/2 is equal to 1x, and that's equal to negative 12. So as you just say this, if you say 1/2 of some number equals negative 6, well, 1/2 of negative 12 equals negative 6. And so that makes sense. And if you plug negative 12 in up here, 1/2 of negative 12 is negative 6. 7 minus 6 is 1, but it's a positive 1 because there's more positives. And a negative 12 plus 13, well, 13 minus 12 is 1 also. It's a positive 1 because there are more positives. So x is the solution to this equation up here. I'm sorry, x negative 12 is the solution to this equation up here. Okay, another way to work with that 1/2 x is to multiply through by 2. So if you multiply this entire expression by 2 and this entire expression by 2, you can look at this as using the distributive property. So it's 2 times, basically what you're doing is multiplying every term by 2. And so I could just go ahead and do that. 2 times 1/2 x is 1x. That's way down here. So 2 times 1/2 x, 2 times 7. So that's 2 times 7, or just 2 times this 7. 2 times x, so 2 times this x, or just 2 times this x. It's the same thing. And 2 times 13, or just 2 times 13. It is the same thing. So 2 times 1/2 x is x, plus 14, 2 times 7 is 14, equals 2x plus 26. So 2 times 13 is 26. So you can get rid of this x by adding a negative x. So 2x plus a negative x, or a negative 1x, is 2 minus 1 is 1. So that's going to be a positive x, or a positive 1x. And 26, add a negative 26, 14 plus a negative 26. Well, 26 minus 14 is 12. But that's going to be a negative 12, because there's more negatives than positives. So again, you get x equals a negative 12. And one last way to look at this is really just look at it very simply as this is going to be 1 minus 1/2. So 1 minus 1/2 is 1/2. So this is 1/2 x. You can also look at it as plus a negative 1/2 x. Same thing. So 1 plus a negative 1/2 is a positive 1/2. So this is 1/2 x. And 7 plus a negative 13 is a negative 6. 13 minus 7 is 6. But that's a negative 6 because it's 7 plus a negative 13. There's more negatives. So then you get down to here, same thing as before. And 1/2 of some number equals negative 6. Well, that number is negative 12. So 2 times negative 6 is negative 12. So that gives you the answer of x equals negative 12. This is problem D. And an interesting way to do this problem would be to go through and write out each step, and then have a second student go back through and describe what was done for each step. So here are the steps. You get through to an answer of x equals 0. So what was done in this first step? What's the student doing here? And the main idea is to get rid of what's inside these groups, to get rid of these parentheses. And how do you do that? Well, in this case, the student used the distributive properties. So they distributed the 2. It's as if you have 2 groups of x plus 7, and you're taking out the x's from those 2 groups. So there's 2 of them, and you're taking out the 7's from those 2 groups. So there's 2 7's, which equal 14. And then you're left with, on the right side, you still have a negative 4x plus 14. So now we have x's and we have numbers. And so now we're going to get rid of the numbers on one side, move those over to the other side, and move the x's over to the opposite side. So what was done next says divide each term by 2. You don't really have to do that, but you can. So you go through and you divide each of these terms by 2. Another way to say that is you multiply each term by 1/2. So 1/2 of 2x is 1x, 1/2 of 14 is 7, 1/2 of a negative 4x is a negative 2x, and 1/2 of this 14 is 7. Now notice here you have x plus 7, and you have a different expression, a negative 2x plus that same 7, yet they're still equal to each other. So you're adding the same amount to 2 different numbers, and they remain equal. There's only one way that can happen, and that's down here. X has to equal 0. So that's where we're going. So the next step is to remove the 7's. So I'm going to add negative 7 to both sides. Well, I'm going to add negative 7 to this side. Usually we say that that moves the negative 7 over here. Add a negative 7 to this side, and there's whatever's left by doing that addition. But in this case, you remove the 7's from both sides. So you end up with x equals negative 2x. Well, that can't be unless x is equal to 0. So we're going to get all the x's on one side by adding a positive 2x to this side and a positive 2x to this side. Well, x plus a positive 2x is equal to 3x. So you're left with 3x equals 0. And if 3x equals 0, 1/3 of 3x, or x also has to equal 0. So if you have 3x equals 0, then if you take 1/3 of these 3x's, that's 1x. Well, 1/3 of 0 is also 0. 1/3 of nothing is nothing. So multiply both expressions by 1/3. 1/3 of 3x is equal to x. 1/3 of 0 is still equal to 0.